Hey guys, welcome to day 2 of week 6 of chemistry. So if you've been paying attention in the last couple of videos, I've been saying that I would post a video on how to balance redox reactions. Okay, well, when I actually reviewed over this, I realized that I didn't learn how to balance redox reactions until I was in college. So I think we're going to hold off on a portion of how to balance redox reactions, and what we're going to do instead is rather than balancing them, I want you to be able to fully understand how to read them and to do like the first couple of steps in balancing redox reactions without actually getting to that final product. Because it actually really is complicated. There's adding hydrogen ions and water involved and all that kind of stuff. And it's something that if you go on and study chemistry in college, you will be all set and have the pieces of the puzzle ready to put together if you want to go deeper into chemistry. I have a little cheat sheet up here for you as we go through these problems and just take a look at them. So we have reduction, which means we're gaining electrons. So this is how you write electrons shorthand. It's an E with a negative next to it. So we're gaining electrons, which actually means our oxidation number is going to go down. And then with oxidation, remember reduction and oxidation have to happen simultaneously. That means we're going to lose electrons, and so our oxidation number is actually going to go up. Let's take a look at this because you're actually going to learn how to write half reactions, if you remember that from the first video. So there's a couple of different things I'm going to want you to be able to do with a problem like this. So we have Ag, which is silver. We have nitrogen and we have oxygen, and then silver, nitrogen, and oxygen. All right, so I would want you to be able to figure out the oxidation number of all of these elements. So we'll do that in just a second. I also want you to be able to know how to write what's called half reactions, which we talked about in the first video briefly, and I'll show you how to do that in just a second. The other thing, so there's 3 things total I want you to be able to do. The other thing I want you to be able to do is look at this and tell me, once we figure out the oxidation numbers for each piece, tell me what is being oxidized, what is being reduced, and what is the oxidizing agent, and what is the reducing agent. Now, if all of this language sounds new to you, you need to stop and go back and watch all the videos, okay? Because we're going through a lot of things that build on each other, so I want to be sure everybody has a clear understanding of it. First step, we're going to figure out the oxidation number for each piece in this equation. All right, let's start with silver. So make sure you have your rules out. I have mine out. So do we have a rule when it comes to silver? No, we don't. But we do have a rule that says anytime an element is by itself, its oxidation number is going to be 0. This element is by itself, so the oxidation number is going to be 0. So I wrote the problem wrong. There should be a negative right there. And that might seem like it's not important, but it's very important for this next part here. So sorry about that. It is written completely correct now. All right. So let's take a look at nitrogen. Do we have a special rule for it? No, we don't. What about for oxygen? We do. Oxygen's oxidation number is usually -2 unless it's with peroxide. So we have 3 oxygen atoms that we're dealing with though. So we're going to have to multiply it by our -2 oxidation number, which gives us a total oxidation number of -6 for oxygen in this neutral compound. So we know that this this is not a neutral compound because we have a negative here, which means it's a polyatomic ion. I was getting a little excited there. So we have a negative here indicating it's a polyatomic ion, so the sum of our oxidation numbers is going to equal our ion's charge. And in this case, we just have a negative, so that means it's an understood -1, right? So this whole compound right here, its oxidation number is going to equal -1. The sum of the oxidation number will equal -1. All right, so what would nitrogen have to be with -6 in order for this to be -1? It would have to be +5. All right, so moving on, we have silver's oxidation number. What would that be? Well, take a close look. It wouldn't be 0 because we do have a charge being indicated here. And we know with monoatomic ions, the oxidation number is also going to be equal to its ionic charge. So plus with no number next to it indicates to me that that is an understood 1. So silver is +1. Now let's take a look at nitrogen on this side. Do we have a rule for nitrogen? Nah. Do we have a rule for oxygen? Yep, -2. We know that this is going to have to equal 0, so what does nitrogen have to be? +2. All right, I took out all the extra writing so that way nobody's confused. So we're going to take a look at what is being oxidized and what is being reduced. So let's first look at silver, because remember, if something is being oxidized, another something has to be reduced, right? So we're going to figure out what's doing what here. So let's take a look at silver. So silver, its oxidation number goes from 0 to +1. So using this little cheat sheet up here, what is happening? Our oxidation number is increasing, right? So silver is being oxidized. What this actually means is that silver is losing an electron. It's giving up an electron. All right, let's take a look at nitrogen. What's happening with nitrogen? Well, nitrogen's oxidation number goes from +5 to -2. So what's happening? Nitrogen has a decrease in its oxidation number, which means it's actually gaining electrons. So nitrogen is being reduced. And even though the oxidation numbers look different, really the core oxidation number of oxygen in this problem is -2, right? So nothing is actually happening as far as oxidation or reduction is occurring with oxygen. So with this information, we can also figure out what the reducing agent is and what the oxidizing agent is. We know that it's opposites. So the silver is actually the reducing agent because it is responsible for reducing nitrogen. On the flip side, nitrogen is the oxidizing agent because it is responsible for oxidizing silver. So silver is being oxidized, it's the reducing agent. Nitrogen is being reduced, it is the oxidizing agent. And just remember that silver is actually losing electrons while nitrogen is actually gaining.
All right, let's take a look. It's not even in the, okay. All right, let's take a look. Let's take a look at the second one. So the first step that we want to do is figure out, my laundry basket. God bless you.
So the first step that we're going to do is figure out the oxidation numbers for all of them. So if this kind of problem was on your test and I asked you for the oxidation number for each element, I would expect you to be able to do it for me. Okay, so let's figure out zinc first. So zinc, we can look at our rules, but I can tell you right off the bat that since it's all by its lonesome and there's no ionic charge with it, it's going to be 0 as its oxidation number. Do we have any special rules for nitrogen? No, we do not. So let's take a look at oxygen. What about oxygen? Yes, we do. -2 is our oxidation number. Remember that this is a polyatomic ion, so the oxidation number sum is going to be equal to the polyatomic ion charge, which in this case is -1. So we want to be sure that this fully equals out to -1. We have 3 oxygen atoms, though, so it's going to be multiplied by 3. So really we have -6 total oxygen, although each individual oxygen still has an oxidation number of -2. But together it's -6 because there's 3 of them. So nitrogen has to add with -6 to get -1. So what would that be? +5. What about zinc on this side? Zinc on this side is a monatomic ion like we had with silver. It's going to be the oxidation number is going to equal the ionic charge. So it's going to be +2. Okay. Nitrogen doesn't have any special rules. Oxygen does, though. It's going to be -2. Why did I just erase that? It's going to have an oxidation number of -2, but there's 2 oxygen atoms, so we would multiply that by 2. So the whole oxygen together, both oxygens together, are going to have an oxidation number of -4. This is going to add together, the oxidation number sum is going to equal 0, right? Because this is a neutral compound. So nitrogen has to be +4. I took away some extra writing so that way there's no confusion. So let's take a look at what is being reduced and what is being oxidized. So we know that zinc goes from an oxidation number of 0 to 2+. So it is actually losing 2 electrons because its oxidation number is going up, which means it is actually going to be oxidized. Whereas nitrogen goes from +5 to +4, it is actually gaining 1 electron. So nitrogen is being reduced. Kind of a good way to think about that is if we have 5 electrons and then we add another electron to nitrogen, it's going to be +4. This is how we write electrons, remember. So you don't have to know that, but it might be a good visual for some people. All right, so what's happening with oxygen here? Well, if we looked at oxygen's individual atoms, we know that the oxidation number is going to stay -2 for each atom of oxygen. So the atom number is changing in this problem, but the actual electron transferation, I just made up a word. The actual number of electrons being transferred with oxygen from here to there stays the same. It's -2 to -2, okay? Just be sure that you realize that even though the atom number changes, so here we have 3, here we have 2 oxygen atoms, the number of electrons has not changed, so therefore oxygen is neither reduced or oxidized, it just stays the same. Right, if zinc is being oxidized and nitrogen is being reduced, which one is our reducing agent? Remember, zinc is going to be our reducing agent because it is responsible for the reduction of nitrogen, okay? It loses 2 electrons by oxidizing and gives over to nitrogen, which nitrogen is gaining electrons, and so therefore it is being reduced. On the flip side, nitrogen is being reduced and gaining electrons and taking electrons away from zinc, so it is the oxidizing agent. So zinc is reducing agent and nitrogen is oxidizing agent. All right, let's write our half reaction. So if I were to ask you to write the half reaction for the element that is being oxidized, you would say zinc. Don't write the oxidation numbers above it, but you do need to, oh, that looks like a Z. You do need to write the charge next to it. All right, and then if I were to ask you to write the half reaction for what element is being reduced or what compound is being reduced, it would be NO3 minus, don't forget that minus there, and NO2. All right, guys, if you have any questions, please let me know. I will be more than happy to ask them. The next video is a test review. You don't have anything else due for me this week other than just study for your test, which is on Friday, May 1st at 1:30 p.m. via Zoom. Love you guys.